Hello, everyone. In this video, we continue our work setting up and simplifying difference quotients. So we're now going to look at the example when our function f of x is equal to 1 over x. So as we've been doing in the previous videos, first let's compute or determine what f of x plus h would be. So into my x for the rule of f of x, I'm going to plug in x plus h. So let's do that together. That would look like 1 over x plus h. So now let's set up that difference quotient. Again, f of x plus h minus f of x all over h. All right, so let's plug in the forms of our function. So f of x plus h is first. So we have 1 over x plus h. And I'm going to use a lot of parentheses here because I have a lot of rational terms going on or fractions. So I just want to make sure I keep everything clean. So then I'm going to subtract f of x, which is 1 over x. And all of that I'm going to divide by h. So now for simplifying. So when we have a numerator with fractions, as we see here with the difference of fractions, what we're going to do is subtract those fractions together. Meaning we need to find common denominators in order to combine these fractions. So I'll just write that out here. So find common denominators to subtract fractions. So what that looks like, our first denominator is an x plus h, then we have an x. So common looks like we just have to multiply both by the denominator of the other. So that would look like multiplying the first term by x over x, and the second term multiplying by x plus h over x plus h. So let's continue at what that would look like. So we have x over x times x plus h minus x plus h over x times x plus h all over h. So now the fraction in the first, this numerator here, has the same denominator. So now we can combine numerators. So we get x minus x plus h. Again, I'm using a lot of parentheses here, over x times x plus h all over h. And it's important to keep parentheses around what the numerator is so that we don't get confused of where our fractions are stacking here. All right, so now I'm going to bring in that negative into both terms in the numerator. So that looks like x minus h all over x times x plus h all over h. We'll take a moment to pause and see if we can simplify anything in the numerator. We see this x cancels with this minus x, so these two terms cancel, and we're just left with h over x times x plus h all over h. So this dividing by h here, we see in this fraction is equivalent to if we took 1 over h and multiplied by our numerator. And the reason why I'm setting it up like this is so that we can see a bit more clearly how we are going to simplify our term. So again, all I've done here is replaced our dividing by h with multiplying our numerator by 1 over h. Now I'll take a moment to ask you to see if you can see what we can simplify at this point. Well, this h in the numerator cancels with this h in the denominator. So we're left with 1 over x times x plus h. So our final simplified difference quotient looks like 1 over x times x plus h. And again, we're seeing that if we plugged in h equals 0, so we can say h equals 0 would make 1 over x times x plus 0, which would be 1 over x squared. So check, We are able to plug in h equals 0. So that means we, or also confirms that we have simplified enough.